Welcome back to our Automated Machine Learning lecture series. Now we talk about when to use AutoML. There's a simple saying, you can measure it, AutoML can optimize it. So whatever you can measure, it's very simple also to be optimized for example, accuracy, training time, inference time, memory consumption, energy consumption, sparsity, which is then related to interpretability. Of course, interpretability is more than sparsity, but fairly connected. If you have a certain fairness metric in mind you would like to be optimized, you can also do that. What AutoML can't, at least not directly optimize for, is trust of users or user experience. Fairness in general, so if you don't know what kind of fairness metric you would like to use, and it's very hard to say that. So you need at least to have a first understanding of what kind of fairness you need, and then you can optimize it for, but not directly fairness in general. Human-driven feedback, aesthetics of images. So at least you can't do it directly. If you ask humans to rank stuff, to have preferences on certain images, of course you can again do it, but then more not in the direct way. So you first need to figure out how to measure things. Business impact, revenue increase. Of course, if you're having one better, I don't know, recommendation or label, what it really means in terms of money, you can also do it, but it's not directly. So it's always more indirectly over that kind of accuracy. Emerging properties, vulnerability to unknown adversarial attacks and so on. If you can't directly measure it, of course, we also have a problem. So you should always think about what you can measure, and maybe is that also a proxy at least for something which you can then indirectly at least optimize for. But most people really think in these terms in doing AutoML and thinking about if we really care about these kind of things, can we map them actually to that? Then the question is, if you have a large space of possible models or pipelines component, you can use, of course, automated machine learning on that, because humans are fairly bad at navigating huge design spaces if there's no intuition behind it. And AutoML is quite nice, for example, to come up with the first prototype. So you say, okay, here's my data. I don't really know what it is. I don't know, do I have linear effects? Do I need a tree-based model? Do I need a very large neural network whatsoever? AutoML can find you these kind of first prototypes very efficiently. Of course, if there are already known constraints on the machine learning, to really say, okay, here for my project, I need XGBoost for whatever reasons, you should consider these and not apply automated machine learning. So if you have the knowledge available, go with that knowledge first and check whether you are happy with it. Only then, if you say, okay, there should be maybe more to it, or maybe it's not doing the job, then you can also go to something else. Very similar, if you have no good baseline or miss your expertise, you can use automated machine learning. Sometimes even experienced machine learning developers lack an intuition of what to try out first if they're confronted with a completely new task. Also, non-technical users, domain experts, I don't know, in machine learning, in medical fields, in whatever you would like to have it, often don't have this kind of knowledge you might need to run a machine learning pipeline very efficiently. And therefore, AutoML can help you with identifying promising direction and exclude non-working approaches. Again, in that kind of sense, AutoML for rapid prototyping, for example. You should not use directly automated machine learning if you already know a promising baseline. For example, on a similar data sets you already have experience, you should try these out first. Especially AutoML often need more compute compared to a single model training. So if you're saying you can only afford a single model training, or if you're saying you already know what kind of model there has to be for whatever reasons, go with it. If you're saying you will try anyway 10 different models more now because you're not very certain about what it should be, go with AutoML instead. Then the question is, are well-performing hyperparameters available to you? So you can use automated machine learning. Beyond trying out default or well-established settings of hyperparameters, humans are fairly bad in trying out different hyperparameters because You know, for an architecture, you might have some certain kind of intuition if you're an expert. For hypernomials, everything gets much more harder because these are numerical values, not really with the structure. You don't really know how everything interacts maybe with each other. So especially for hypernomials, it gets very quickly nasty and hard to do things. Oops. Don't use automated machine learning in that setting if you deal with a well-known data set. For example, ImageNet. There are often very, very performing hypermodal configurations for all kinds of things because ImageNet is one of these data sets. I don't know how many thousands or millions of papers are out there on that data set. So, you know, simply use what people already found. Of course, you can also combine that again with automated machine learning. If you say, okay, maybe I would like to run automated machine learning nevertheless, because maybe it's not quite ImageNet-like, but something similar, but you don't know how similar it is. So what you can do is going with first these kind of established default configurations, and then based on that, you're running automated machine learning more as a warm starting with that already valuable information what worked well in the past. If you're talking about explainability and documentation, we can use automated machine learning because results of automated machine learning tools means performance of different models can be automatically saved and reproduced, right? Because we can document that in a very nice way, and we can actually do even more. We can use these kind of empirical results to feed into explainability methods. They can give you some kind of insights, for example, which were the most important ones. What is interacting with each other, and more and more. Don't use automated machine learning if you know that you might have some kind of constraints on things, for example, on explainability, and you need certain kinds of explainability. So some AutoML tools generate fairly complex models, for example, stacking and ensembling, or very large neural networks, which might be hard to interpret than simpler models with less accuracy. So that's a bit of a trade-off sometimes, what kind of explainability you need for legal constraints or for whatever reasons. And then you need to make these kind of decisions actually that you might need to go for a very simple model to satisfy these constraints. We can still use automated machine learning, but then on a very more narrow kind of model space, hypothesis space, or configuration space. But you should always be aware of what you're doing and what kind of output you're expecting with that. Then fairness in automated machine learning. If you already know that there exists a fairness method which is relevant for the application, you can use automated machine learning for setting these kind of constraints on fairness. So for example, mitigating the discrimination with that. If you do not know which fairness metrics to use, discrimination could be a problem for your application, you should not blindly apply automated machine learning. Because if you not consider fairness at all, you might have unwanted results at all. So you don't know what's actually happening on the fairness side. And if you're saying, yeah, come on, there's a bunch of different fairness metrics, I'll choose only one of them, it will be fine. That's actually not true. Depending on your application and the social framework around that, you need to think about what kind of metric is the correct one. So what I'm saying here is, first think about what kind of metric you really need, deeply, maybe with domain experts even to that. And then you're going to use automated machine learning when you know what to optimize for. So the most important insights from this video, AutoML can be very useful to increase the efficiency of developing new machine learning applications. AutoML can do a lot of things for you, but there are certain aspects that cannot be automated. For example, we talk now about the fairness metric itself. So AutoML can't decide for you what is the metric. If you give the metric, know what it should optimize. Of course, AutoML can optimize it for you, but the decision, which metric, that's up to you or other stakeholders of the project. If you already have insights into your problem, make use of them first. I always say, don't blindly simply only use automated machine learning. Automated machine learning is great, definitely. But if you have your expertise, use it. If you're not satisfied with the results, go give it a try with AutoML. With that, I hope you have a better perspective of when and how to use it, and I hope to see you again in the upcoming videos.